Hello, everybody, and welcome back to Unit 1 of Regents Chemistry course, which is Math of Chemistry. Today, we will be talking about the prefixes and the SI units. So, you guys are given a set of prefixes in Table T in your reference table packet, which is on page 1. Um, and some of these prefixes might look very familiar to you. For example, if you look at this first one, kilo, we have all heard of kilometer or a kilogram, or we have all heard of a centimeter, or we have all heard of a millimeter. So these prefixes are not something that we don't use in everyday life. Most of these we do use every day. But why do the scientists need this? Remember this number when we were talking last time about the scientific notations, and we said that, well, scientists were making these measurements and they were getting very large or very small numbers, so they figured a shorter form to write that, which is called the scientific notation. Let's write one for this one. Remember, we said that we want our decimal to be right after the first non-zero digit, which in this case will be 5. So now we move our decimal so that it can be right after that 5. So that would be 1, 2, 3, 4, 5, 6. 6 times to the right. And our number will now become 5.6. And because we are moving the decimal 6 times to the right, the power of 10 will be negative 6. Okay, so do not forget your unit. Now here's the thing. When scientists came up with the scientific notation, now they wanted to have an even smaller form to write these numbers because they were like, oh, we don't want to write all these powers of 10. So why don't we just come up with like a shorter form of them? So if you guys try to find this 10 to the power of 6 in this table, there we have it. And the prefix for that is micro, represented by that small u. All we can do here is write 5.6, that 10 to the power of 6 can be substituted by this micro, and then we can just have our meter with that. And there you go. We have an even smaller version to write that scientific notation. That's exactly what we use the prefixes for. So if I say that I have 1 kilogram, that basically just means I have 1 times 10 to the power of 3 grams. When I say I have 1 centimeter, what I'm saying is that I have 1 times 10 to the power of negative 2 meters. That's basically what these prefixes do. So remember once again that they are on page 1 in your reference table packet. And basically the way this table goes is that the first prefix that you see on the top, the kilo, that is the largest in this table, and then the prefix all the way at the bottom of this table, which is pico, is the smallest because it's 10 to the power of negative 12. Now prefixes are always used with units. So when we talk about units, the problem that we had in science was that when we go to different places in the world, pretty much everyone, not pretty much everyone, but in different places, people use different units for different things. For example, we use Fahrenheit for temperature, but for the rest of the world, they use degrees Celsius. Uh, we use pounds for weight, but for the rest of the world, for the most part, people use kilograms. So that's one problem that was causing a lot of issues in scientific research because let's say the research that people in the US were conducting, people in somewhere in the Europe were not really able to understand that because were using different units, or those numbers were just not making sense to them. So that's why scientists thought that, we want to make sure that we have like one fixed set of units just for science, and that's what everyone in the world, doesn't matter where you are, that those are the units that you will be using for science specifically, and you will always be using those. So that system is called the International System of Units, and the SI unit um, measurement, the SI units basically consist of these 7 main units. And these are the basic units that do not depend on others, but we can derive a lot more units from them. So we will only be focusing on the first 5. You guys don't need to know the last 2 for this course. So as I said, the 7 units in the SI system, they are like the basic units. And then we use those units to derive a lot more units out there in the world. So in your reference table on page 1, you guys have this table D where they've given you like the all of the pretty much all of the units that we will be using in this class. Today we'll only be focusing on the unit for mass, we will be focusing on temperature, and we will be talking about the volume. That's what we'll be talking about today. As we move forward throughout the school year, we'll be talking about the rest as well. So volume is basically how much space something is occupying. Okay, so when we have this cube, uh, and it's just like on your table, wherever it is, we are just trying to say how much space is this Rubik's cube occupying, and that is the volume of this cube. Same thing with a soda can. So let's say when we say we have a 16-ounce soda can, that basically means the volume of that liquid in there is 16 ounce because it is occupying all the space in that 16-ounce container. Okay, that's how volume works. Now, when we are talking about the volume of solids, please remember that it is always measured in either meters cubed or centimeters cubed. Why is that the case? Because volume is equal to a volume of a solid is equal to length times width times height. So all three of these units are measured in meters. Let's say they are measured in meters. So that would give us an overall unit of volume to be meters cubed. If they are measured in centimeters, that would give us an overall unit of measurement to be centimeters cubed. Because meters times meters equals centimeter equals meter cubed. Same thing with the centimeters. But if we are looking at the volume of a liquid, that has to be in liters or milliliters. Now, when we talk about mass, mass is basically how much matter something has. And for the most part, it can either be measured in kilograms, grams, those units. For the most part, we don't really get the exact mass of stuff because when you stand on the weighing balance, you get your weight. And your weight is different than your mass because weight depends on the gravity. It is the force that you experience because of the gravity. So whatever weight you see on the weighing balance, that's actually not exactly how much your mass is. It's sometimes less than that. So hopefully that makes you a bit happy. And then finally, let's talk about the temperature. Temperature is defined as the average kinetic energy. Why? Because kinetic energy is the energy of motion. When something is moving, it has kinetic energy. So when we say that temperature is the average kinetic energy, we are basically just saying that temperature depends on the movement or motion of particles of anything. So when we are looking at the temperature of water, we're just looking at how fast or slow its particles are moving. When we are looking at the temperature of a gas, we are just saying how fast or slow the particles are moving. Okay? So as you guys see in this example right here, when we have um, our temperature very low, the particles are going to move slowly. But as we keep increasing the temperature, the particles are actually going to move faster and faster and faster. So the scientific unit for temperature is Kelvin. It's not degrees Celsius and it's not Fahrenheit. For science, it's completely different, which is fair for everyone because it did not favor any specific unit. So we just use Kelvin for temperature in science. And 0 Kelvin is the least temperature that can ever be out there, even though it's not very attainable. Because at that temperature, it's called the absolute zero. At that temperature, there is absolutely no movement of particles, which means there is also no kinetic energy, which basically cannot happen in this world because this world is all about motion. If things don't move, there is no earth. So every single thing is moving out there. So this 0 Kelvin or absolute zero temperature is not attainable. It's not natural. Yes, scientists are trying and they do try all the time to make this in the lab, but this is not something that occurs naturally. There are three temperature scales: Fahrenheit, Celsius, and Kelvin. for this class, we will only be focusing on Celsius and Kelvin. In general, we can technically convert all three of them from one scale to the other scale, but in this class, we'll only look at how we can convert Celsius to Kelvin and Kelvin to Celsius. Okay, so let's quickly look at how can we do that. How can we convert Celsius to Kelvin, Kelvin to Celsius? So if you guys look at table T in your reference table packet, which is on page 12, there you guys are given this equation to convert degrees Celsius temperature into Kelvin temperature. So if you ever get a question where you have temperature in degrees Celsius, you want to convert that to Kelvin, just add 273 to that. However, if you get a question where you have to convert Kelvin to degrees Celsius, how do you do that? Very simple. To start with the equation, K equals degrees Celsius plus 273, and then subtract the 273 on both sides so that it gets cancelled on the right hand side, and now we only have it on the left hand side. So overall, our equation becomes degrees Celsius equals whatever temperature we have in Kelvin minus 273. So basically, if you want to convert degrees Celsius to Kelvin, you add 273. If you want to convert Kelvin to degrees Celsius, you subtract 273. That's how it works. So that is it for this part of the unit. Happy learning. I'll see you guys in the next one.